Hello everyone, this is Splendor Guppy. In this video, I'm going to try out the upcoming feature for random flow and panel cut and show you the changes that are going to be in the next update. There are other changes in random flow. We have random slice, that's a new operator, and also some fixes for panel screws. We have clear bonding, and that's to get rid of the uh, the banding when you use too much subdivision on a cylinder or a cylindrical object. But it's not a perfect solution. But for some basic mesh, this can work. Okay, let's go to random panels. So for random panels, now we have a new property which is called the type. This is inset, and the new one is bevel. So the old or the legacy code is inset, and the new one will be the bevel. So cuts. Okay, let's actually just use a plane to demonstrate this. So with the inset, the surface is raised to create the panel cut detail. But with bevel, the planar surface remains the same, or the planar elevation of the selected faces remains the same, and while the panel cut detail is produced. But the only difference is that by using the bevel type, this is purely destructive, while the inset type can be non-destructive, meaning that the result is another mesh, while the source mesh is kept intact. But you can also merge the resulting panel cut details by using the inset type. You can merge it to the source object, and thereby resulting in a unimesh, or not creating another object for the result, and the details are merged or welded to the source mesh. This is the destructive method. So with using the inset type, you can switch between the destructive method, which is with the merge panel toggle on, and versus the non-destructive method with the merge panel toggle off. So this is our source mesh. Okay. And it also works the same with random panels. Of course, you need to have faces that are selected. So if I mark sharp this, after the edges are marked sharp, you can select the faces. You need to select the faces that surround them, or that envelopes them, or that encompass them. And random panels inset. If you want to get rid of the randomization, you can set the panel size to 100%, and this will only result with the panel cut details using the edges that are marked sharp. There we go. And this is also true with bevel. There you go. So as you can see, the process is destructive, and so if we're using this, if we're using marked sharp edges and no randomization, we can just forego subdivision and use 0. There we go. So the process is destructive. You can also increase the subdivision. And also, so for example, we mark sharp this edge and select only these faces. If we use the random panels, you can see that only the faces that are selected have been subdivided. So this is destructive. slice, tangent, length. But there are, of course, operators in the add-ons to help you repair the topology afterwards. So since this is this process is destructive, you can either save the data using save the mesh data using this feature here. So for example, if I create this, and use bevel. Oh, okay. We need to save the data first. Save, and then we can use random panels for this. So bevel, this is the destructive one, and we have this. So that is destructive. But if you want to use the data again to bring back the original object, so use, so it will say found one matching geometry. Okay, there we go. Or you can do it the old-fashioned way, which is Shift D to duplicate and bring it somewhere here to just, um, so, this is your backup copy. You can hide it and then model this one. So if you're really set on the design that you've made for this, then you can just probably delete this or press Control Shift S to save and to save another copy of the file as a backup copy. So yeah, that's the way you can manage manage the data or manage your 3D models when doing destructive operations. Okay, let's bring up the panel, the plane again. So this is the random panels. As you can see in Bevel, all these other features using the inset type are not available in the bevel type because of the way the faces and the edges are being referenced. So they can be easily referenced using the inset type, while in bevel, not so much. And because of the way the geometry are developed or the panel cut details are made, some of the in bevel type, for example, some of the features that are in inset type cannot be replicated in bevel. Like for example, the bevel ups, the beveling of the corner verts, it cannot be done here because the way the operation works is this is how the inset actually works. Inset. So if I press I and then individual, so this is how the inset type works. Okay, to create that final cut detail right here, for example. But in bevel, um, it means exactly what it says. So bevel, instead of inset, it's using bevel, creates the middle edge, and then reference the vertices in those middle edges. Then push it towards the mesh, and then we have the final cut detail. Okay, so because of how this how this final cut detail is created, some of the features that are available only for inset cannot be done with the bevel type. Okay, but a good thing about this is that even though it's destructive for geometries like this, for example, if I use inset, and where's the okay, we're going to switch this back to defaults and flip the normal. Okay, there we go. This corner vert here is creating the spike in the geometry. But you can avoid this in the next update by in the inset type by using the non-even in the new property inset mode, the non-even choice or option, or using bevel, even though it's destructive, can let you avoid geometry spikes in most of the, okay, what's this one? Oh, most of the geometry anyway. Okay, what is inset bevel? What is that? Oh, I get a duplicate. Okay, so that is inset. Well, we switch to bevel, and you can see that in the generated panel cut is distorted in this kind of geometry, this area of the geometry, but we don't have the spiking. At least we don't have the spiking. Okay. Okay, let's go to panel cut. So panel cut, okay, panel cut works. If I select this and use inset, where's the error message? There should be an error message. Okay. If I use panel cut inset, you can see that no selected faces and or mark sharp edges. So the way this works is that you mark sharp the edges first, and then select the faces that covers the mark sharp edges that you want to use as the panel cut detail. So for example, only this part here, and then we use panel cut. Okay, so the border also gets is of course can easily be seen the border of the selection, because using the inset type you can see that the faces are elevated to generate the panel cut effect. Okay, so this is this is non-destructive, and we can also use inset and then merge to merge the effects, and this is destructive using the inset type panel the inset type panel cut operation. So this works on like random panels, but without the need for subdividing, because this operates on non-subdivided topology and works on the edges that you marked as sharp. This is for the inset type. The inset type needs a face selection, and inside those face selection, it needs those edges marked as sharp that you want to be the panel cut detail. So that's how the inset type works. But now we have the bevel, and in random panels, so in random panels with bevel, you still need faces selected, not edges, not verts. But with panel cut, now I was worried about, I always wanted panel cut to be a separate, for its functions to be more distinct than random compared to random panels, other than just not using subdivision, of course. So this makes panel cut truly an its own individual add-on, separate from the random flow algorithm. Okay, so panel cut, create we don't need to select faces anymore. We just need to select the edges that we need as panel cut details. So like that, for example. And you can do this in edit mode or in object mode. Panel cut and use bevel. Okay, select this. Panel cut, bevel. Okay, so this process is destructive, and also the features that are available for inset is not available in the bevel type. Okay, we don't have clear sharp or merge panel. Probably clear, yeah, or merge panel. We don't need it because, of course, this is purely a destructive operation. So it doesn't trace the topology. So inset raises the topology, while this one here, because this is destructive, this keeps the planar elevation of the mesh like that. You can select another one, that, like that. So with the mark sharp edges, you need to have the edges connect with each other or connect with the outer limit of the face selection in order for the um, edges to be contiguous and not result in geometric distortions. But with this one, you can just select anything, even a non-contiguous selection. Contiguous selections means that the selection of the edges are closed, or it connects to another edge, or it connects to a non-manifold edge like this one. So with this one, with the bevel type in Final Cut, you can just select whatever edge and Final Cut. There you go. You can design the mesh first, like that, and Final Cut. There you go. So the only caveat is that for you can see the this geometry here. If I select this and Final Cut, you can see this vert here is not connected here. Okay, so um it's I can get this using script, but it will be uh for a simple mesh it can work, but for really complicated mesh it's really not that reliable. So instead I'm going to leave it as is and just let the user or you repair the topology afterwards. So I'm just letting you know that this is the result for this kind of so you can just select this and then M and merge to last. Okay, so if I'm going to use script to repair that, for example this one, and Final Cut, you can see the problem here. I need to get this, I need to reference this vert, okay, and then if I get this vert in the script, then I need to get the closest vert from it and then merge that vert to this vert. Okay, so the closest vert is this one. But um, because some parts of the mesh might be really complicated, so uh, like this one. So for example, if it has that one, it might catch that and link to that instead. Okay, so in the future, maybe there will be a more reliable fix for this, and when you merge it like that, uh, yeah, you have other problems for this. So it's not that reliable for now because of the maybe how can I reference this? So this word right here, one, okay, 1 2 1 2, and so this vert right here, I'm counting the faces. So this vert, so I can get this in the script, this face is here. So in order to get this, I'm going to say that this vert should, in order to get this vert should have only two faces, two linked faces that are not included in this Final Cut faces. So this one, I can get it. But this also meets the condition. You see, this word here also has two faces that are not part of this, and this one here also. So this might be harder to actually reference in the script in order to merge it to the nearest nearest vertices. Okay, so maybe in the future I'll find a solution for this. But for in the meantime, when the update hits, you know what to expect. But of course, let's try and model something like a hatch or something. Okay, auto mirror X and Y, B, AO, B. I mean I B. Oh, okay. Doesn't work like that. So I'm just gonna quantify this and B, I, B, trying to create a, there we go. So I can raise it up. So just a simple model. Gonna draw something here, and I'm just gonna quantify this after and raise it up. Get rid of the border in the center line. Raise this up and draw something here and extrude it down. Okay, so now we have our base topology. Actually, we don't need to actually make this into a quad because the panel cut detail can be generated using just the selected edge. But you know, um, we'd have more edges to play with, so let's do it. This is 0.01. Okay, 0.02. There we go, and let us just prepare the topology. Okay, this one, this. Okay, one right here, view. And increase the topology right here. We need to fix this. I'll just use the knife and press A. So this one here is, oops, 0. Oops, scale to Y, 0, just to straighten the edge. Oops. What the? Okay. I wanted to fix this. Okay. Don't need this. And we don't need this. So this is squad. This is ingon. So why am I trying to quantify this? So when I use Control R, I can easily use I can easily add um, edge loops using Control R. You see that it doesn't go past ingons like that. So this is an ingon, and this face loop heel is purely quad. You can see you can add that quickly, but here it stops. Okay. This one here. Oh, that is a quad. And let's just connect here this to here. scale this to the active element to, there we go. Yeah, I guess this could, wait, there's a better way. There we go. So did you know how I got really good at codifying stuff? And it's because of ingons and tries, not because of quads. So when I modeled 3D models from before, I used to design it first, then just bother with topology afterwards. It's much faster, and it's also a good practice for modifying the topology. Okay, let's create the panel cut details. Let's start with this one here. Let's try the knife. Okay, this is probably, okay, let's try the knife here. Press A to activate snapping. Okay, let's select this faces, and okay, select this face. Okay, let's make it slant towards that edge. And final cut bevel. Let's set the bevel width to something like that. With offset, you know, this this affects the middle edges that generates the final cut detail. You can actually, instead of forcing it towards the mesh, you can force it outwards, or force it, instead of forcing it inwards, you can force it outwards to create that effect, this effect. So for now, let's just use the default. Okay, we have that one, and we can also draw something like an arrow here and bevel this, reset the, I mean, not reset, modify the width. So we have that, and let's try this one. Draw cuts. I don't know if it will work with symmetry lines. It doesn't. Okay. Yeah, that. You can of course select the faces and press Alt S to bring it up or down. Let's see. Length flat faces. So you can create that effect just like that. And we can actually bevel this like that. And so yeah, this if for example, when using random flow, the random panels, for example, inset, oh, just one, using too much. I'm lucky it didn't crash because from the initial operation it was using too much of the vision. So when you're using random panels, for example, and the randomization just won't give you anything that looks good or that you could use, a pattern that you could use based on your current design. Actually, this looks good, but just in case it doesn't give you, um, I mean, anything useful, you can just design the panel cut detail yourself. So you can use panel cut using the um, process that I've just shown you. Just selecting the edge and using the panel cut operation. Let's use it. Okay, so selecting these edges here and this one here and this one. So if you want to use, actually, this might be too close. So let's make it wider in order for the panel cut width to be more. So we can have a wider panel cut width. Panel cut width or offset. Okay, so if you're using if you don't have panel cut or you just have random flow, you can mark sharp this, then select the faces that encompass the or covers the mark sharp edges. Make sure that the proper face border or edge border are selected. If you deselect this, then operate it just like that. Shift U, random panels, radial. Use set funnel size 100% and also 100% here. And since we're just using the mark sharp edges, we don't need subdivision. So panel size 100, 100%. So this is inset. This is either going to have this is going to generate raised or elevated face, but you can of course merge or unmerge it. But with bevel, it's just going to use the current mesh. And you can see that the border right here, because the faces here are not selected, it created a border in that part. So for example, inset, you can see the border, and this is the raised elevation. If we use bevel, it also generates edges on those borders. Okay, so include these two and then use the operation. Okay, mark sharp edges. It only use the mark sharp edges. Actually, it's not supposed to cut this, so I'm going to add an additional property here that avoids certain edges based on their sharpness. Okay, so 100. Wait a minute. It should work only on the mark sharp edges. Oh, we didn't use the random panels. Okay, yeah. So that was panel cut. It's supposed to work on selected edges. So this is, yeah. So this is random panels, and it didn't work on this one because it's not supposed to work on edges that are very sharp angles, So yeah, like that. But with panel cut, you need to mark sharp the edges. Unless you're using the inset type, it works just the same as random flows, only it doesn't deal with subdivision or randomization. But if we're just going to use the bevel type, you can just select the edges. So clear sharp, and for example, if we just select the edges, and panel cut, bevel, there you go. And you can also create, so this is an in-gun. It's up to you to repair the topology afterwards. Let's see. Again, you can raise the area by pressing Alt S or Alt S. There's a distortion here. probably because of the proximity of the words together, the edges together. Okay, and another detail here that is creating a spike. Wonder why? Yeah, proximity of the edges together. There we go. So yeah, creating panel cut details is as easy as that. And the good thing about this is that these details can be baked, so you don't have to deal with this extra geometry. You can detail your detail mesh and then bake it to the original copy, which has a lower resolution. So yeah, it's in the next update, creating this Final Cut details will be much easier. Control T and Alt J, set this to 180. There you go. Same here. Alt J, Control T, Alt J, and you can just repair the rest. Control T, Alt J. So for this kind of topology, it works great. Alt J, same here. So this is your starter. Then you can repair the topology. Control T, Alt J. Same here. Control T. Control T for to triangulate, Alt J to quantify. And F9 after the codification, and set the max face angle and max shape angle to 180 degrees. Same here. Control T, triangulate, then quantify. And then you can just connecting the two verts, press J, and then press X to delete the edge. X, Control X. There we go. Or you can just Control T. So yeah, I think it's much better to bake the detail. Yes. Okay, so those are the changes that will be coming for the next update. I'm just gonna add an additional property here as well as in random panels in the bevel that will, of course, let you control what sharp edges, what degree angle can the operation cut based on the sharpness of the selected edges or randomized edges. Okay, so that's it for this video, and the updates will be up soon. I'm just hunting for bugs, and in a few days I'll be sending out the emails for the when I update the stores. I'll use that usually means that I will be sending emails that says that yeah, the stores has been updated, blah blah blah. You should go log into the store and then get your free updates there. Whichever store you bought the add-on from, which whether it's from Gumroad or Blender Market, you log once you receive the email, Even if you don't receive the email and you just see me in Twitter or Instagram or Facebook, you see me post that the update is out, then you don't have to actually have received the email to get the update. That means that the update is already in the store. So yeah, log into the store and get the free updates there. Okay, so yeah, that's it for this video. If you have any questions, make sure to use the comment section or the links in the description of the video. Thank you for watching and you have a nice day.